Hello, everybody. I hope everybody can hear me. Can somebody confirm, Lata, maybe that you can hear me? Okay, great. So I guess I will get started. Good evening, everybody. Good morning if you are another time zone. Thanks for joining, and thank you to the IITMAA team for the opportunity to share some perspective. I hope you can see my screen, which you should see a PowerPoint with a chart that says blockchain plus AI. All right, thanks everybody for the prompt confirmation. So I'm going to get started. I chose this topic a little bit for a couple of reasons. I know many of you probably been hearing about both of these topics. We hear a lot about both blockchain and AI separately. And I thought I'll talk a little bit about how we see patterns for these two technologies coming together. So that's what I was going to do. I've been planning to, talk through some of these use cases for, 20, 25 minutes, 20 minutes or so, and then really open it up for you to ask me questions. Okay. Assuming that is okay, if at any point I'm not audible or you're not able to see the screen, just please let me know. I do keep the chat window open. So hopefully you should be able to, reach out to me. I do know this is one way, so the only way for me to get feedback is actually through the chat session. I will start monitoring the questions once I finish speaking. Until then, I'm just going to keep just the chat window open so I can monitor what's going on. Right, with that in mind, let me get started right away. So both blockchain and AI are, are transformative technologies. Both have a lot of potential. Today, I'm not going to be talking about either one of them individually. I'll briefly talk about them just to set context, but I'm hoping that either most of you already know what these topics are about, or at the very least, this introduction will serve to give you a sense of where it is. The focus is actually going to be more on the way these two come together. So that's why the topic is really blockchain plus AI as opposed to either one of them. So here's what I plan to do. I'll talk a little bit about just the evolution of AI, just a couple of minutes as to where I see this going. We see at IBM evolving. Then I will take 5 minutes to introduce blockchain just in case people have not familiar with blockchain. And then we'll get into the patterns where these two technologies come together. Okay, all right. So looks like I have to be in slideshow mode to see the for everybody to see the PowerPoint. Looks like it is back. Okay, so what this chart shows, evolution of AI, this just to set a little bit of context. I'm not introducing AI here because I'm going to assume everybody here has some familiarity of what AI is about. At a top level, it is about making sense with all forms of data, unstructured data at scale, building models around them that lets you understand patterns, predict patterns, and really drive lots of interesting use cases across. And many of us experience it, are seeing it, probably trying to implement it. Many enterprises are already deploying AI, but we're still barely scratching the surface. And one of the inflection points we see from where we are to where we want to go is this whole notion of broad AI, which sits between today's world of narrow AI and potentially the emerging world of general AI, where we build very fascinating intelligence that is as good as human beings are really able to do full-blown cognition. But before we talk about general AI, which will be completely revolutionary, change the face of what we are doing, and today's world of narrow AI, there is going to be a broad, who knows, 10, 20, 30, 40 years of what we call broad AI. And so let me spend 2 minutes on what is the distinction between narrow and broad AI. I'm not going to talk about general AI at all. There is enough science fiction literature around general AI. But let's talk about narrow to broad. So today, most of our AI use cases, whether it is something you have implemented, you experience, whether it's in the consumer world, in the B2B world, tends to be around very well-defined, concrete, quote-unquote, narrow tasks for which enough data is available that you're able to build the appropriate models that do the task as good or sometimes better than human beings. Right? So whether it is image recognition, face recognition, document understanding, extracting, classifying cancerous images as, as radiological images as cancerous or not, etc., etc., etc. Many of us are familiar with these use cases. Today, we know that if sufficient data is available and the problem is well defined, we are reasonably confident with given computational resources, I can actually solve that problem. And as we pick the right problem and the right situations, that is why we are starting to see the impact of narrow AI on many of our lives and many of these use cases. But for AI to really, really scale in enterprises, become broad and disruptive and pervasive, there are a few things that we think need to happen. And what I've listed there are about 5 elements. I'm not going to talk about all those 5 elements today. But what I really want to focus on is trusted AI, because that starts to connect with our other topic of the day, which is blockchain. But let me spend 30 seconds each on each of these topics just to set context. One element here is that a lot of AI today depends on massive amounts of data to be able to build reasonably accurate models. So evolution of technologies, be able to learn from less data is going to be important, because not every enterprise use case or not every use case is going to make available to you billions of images or millions of documents or massive amounts of video or whatever that data is going to be. So the ability to still do useful things with smaller amounts of data is going to be very, very critical, especially if you're trying to model phenomena for which you're not going to have that volume of data. Second is ability to, today, a lot of what AI that we do, every time we start a task, we pretty much start from scratch. Yes, there are some base models people start with, especially in image analytics, people start with a lot of base models and train it. But really the level of reuse and the ability to move from one domain to the other is fairly primitive. There is a lot of scientific work going on in this whole area of transfer learning, where people are looking at how I can learn models for one use case and move on to another use case progressively without that much effort. And that's going to be, again, very critical for the evolution of AI. I'm going to skip trusted AI because I'm going to spend time on it. The other 2 elements are, how does AI work in the context of enterprise business processes? That's going to be very critical. And that requires you to address a lot of elements around how to deploy, how to operationalize, how to make AI compliant, how to make AI safe. Many, many elements of how to bring AI into a business process still need to be addressed. And today there's a lot of excitement. We deploy chatbots, we do basic tasks, and they are valuable. That is why narrow AI is getting deployed. But for scale impact, you're going to need to get AI to be something that can be consumed in bite-sized pieces and embedded all over enterprise business processes. Lastly, today, high-value AI really does take a lot of skills. It not only takes, compute and data and so on, but it does take a lot of skills. So we need better tools so that more people can do AI. And in some respects, I think AI is that answer to that problem also. How can we use AI to develop better AI development tools? And as these tools become better, as it becomes easier to gather, annotate, curate, manage, train, evolve, retrain models, with the system doing a lot of the heavy lifting, just as we have a mature set of engineering tools to build normal application software, being able to have a rich set of tools to build AI applications will allow more and more people, not necessarily only the people with the best data science skills in the world, to build effective AI systems. So that's really why we need AI for AI. And then the middle one is trusted AI, which I'm going to be talking a little bit about. So we see these 5 pillars as being critical for the evolution of broad AI. And of that, trusted AI has a lot of relationships to blockchain. So I'll talk about that after I cover blockchain. So blockchain. So this is a short 2-minute intro okay, I still see a few people telling me they can't see or hear. Can somebody confirm that at least for a few of you, the PPT is visible? Okay, it says screen share is in progress. Okay, let me reshare the. Okay, it looks like some people are able to see, some people are not able to see. So Lata, I'm not sure what to do. I unshared the PPT and reshared it again. Okay. For now, I moved it out of PowerPoint mode. Okay, good. So it looks like when it is in PowerPoint mode, it doesn't work. It only works when it is not in a screen show mode. Okay. All right, sounds good. So I will keep it in this mode. I'm going to now do a short introduction to blockchain for those who have not heard blockchain. So many of you might have heard blockchain in the context of Bitcoin and cryptocurrency. And yes, that is how blockchain began. But a lot of what we see happening in the enterprise around blockchain is really around what you see in the picture today. The ability to create a trusted system of record across a business network. Today, if you look at any type of business network, on the left-hand side can be a banking network, a logistics network, a shipping network, a payment network, a supply chain network, whatever is a network on the left-hand side. Today, a lot of what happens is once you cross organizational boundaries, the boundary of an organization, there is no shared system of record. So, an insurer might have, a buyer might have an ERP system, a bank will have a loan management system, a supplier may also have their own ERP system, an insurer may have a risk management system. All those systems could be digital, we use the latest technology, but anything that cuts across those entities tends to really boil down to sort of point-to-point connections through which you exchange messages, does not create one single shared source of truth. And what blockchain promises and is doing is creating networks on the right-hand side where you're able to create a shared replicated ledger, where all participants, even if they don't trust each other, can transact on common data in one fashion, approve, update, track in a tamper-proof manner how common data across them is getting updated and evolved. So it's almost like, rather than a database system for a company, think of building a transactional database processing system for an entire business network. Ignore for a minute how we do it and the technology, but think of that as essentially what blockchain lets you do. And the reason why you see blockchain being effective in financial services and supply chain, etc., is because a lot of these are systems where transactions today cut across many, many entities. If you do a trading of a stock, the settlement of that trade cuts across depositors, the people who hold the stock, guarantee agencies, the actual exchange, your bank, everything. Or if you do a shipping, then the transaction for shipment goes across the buyer, the logistics vendor, the warehouse owner, the shipping agency, the buyer, the supplier, etc. Okay, you might have lost me along the way because I got disconnected. I lost power wherever I am. Sorry about that. I'm back now. All right. So let me continue with where before I lost power and I lost connectivity. So what blockchain lets you do is create systems on the right. And if you see the core elements of blockchain, it's a shared ledger. It is a permission network enterprise blockchain where you join that network to transact. You are able to create business processes using this concept of smart contracts, and everybody agrees on what's happening in that system. And here are some examples, many, there are many going around. Those of you who are following blockchain will do. At least these are some of the use cases where we at IBM have been widely deploying blockchain from POCs and pilots to many systems in production. And we are running multiple networks across the globe where many of these use cases are being implemented on top of blockchain. So to step back then, we have a technology that allows us to gain insights from data, that is AI. We are starting to now create a technology which is blockchain that lets you create, roughly speaking, database systems for an entire business network, right? As opposed to a single entity, right? That's the picture on the right. So now the question is, how are these technologies starting to come together? So this is probably the most important picture for this presentation now. And what this picture represents is the three patterns around which we see these two technologies coming together. So the first pattern is not very surprising, which is as soon as you start to have data collecting into a system, the first thing people want to do is what can I do in terms of getting insights from the data. So the arrow you see on top is, as we get data onto a network like blockchain, how do I do AI on blockchain? The one and I'll talk about both the challenges and the opportunities. The second one is, both AI and blockchain promise automation. AI promises automation by allowing you to do things that require a lot of human intervention to do it semi-automatically. Blockchain promises automation by saying that business processes that cut across organizations can be done more efficiently and effectively by creating a shared trusted record in a ledger, and so you can do automation. So now how do you bring both of those technologies together to drive even better automation? That's sort of the middle pillar. The last one is blockchain for trusted AI, which is what I told you I will cover after I tell you what trusted AI is about. Okay, so I'm going to first jump into use case number one, which is AI on blockchain. So here is sort of a prototypical example. Blockchain networks are all about collaboration, right? You come together, think of this network being a shipping network. Shippers, service providers, logistics providers, obviously buyers, customs agencies, many people could come into a blockchain network. And there are many drivers for collaboration, right? The reason they come onto the blockchain network is it drives efficiency. On the other hand, the data that gets put onto the blockchain, there are barriers for that. You are putting sensitive business data. Now the question is, how can we support AI at the network level that no one organization can compute, but can be computed collaboratively while respecting the confidentiality and security of each party? There are many examples. So I'm going to talk about one example here, and I call that network AI. For a minute, ignore how it happens, what's the technology, but let's look at the use case. Think of this as being a massive logistics network. One of the things everybody is interested in for the purposes of insurance, planning, etc. is, for example, what could be the average shipping delay across every step of that network? Or it could be how often do breakages happen when a carrier carries a network? And you can translate it into any use case. In a financial network, you may be looking at, how often do people default? How often is there delayed payment? And the questions can be different. But if you could compute, if you could build a predictive model, the AI model for average shipping delays, while using all the data that people have shared on the blockchain network, but without revealing the details that are private and sensitive, each one of them. In other words, across this network, many people will be transacting with each other and sending, let's say, goods through one of the lanes or through one route, using many service providers and shipping many things. If I can aggregate all the data, I can build an AI model. But the problem is all this data is actually owned by different people. And you're going to share everything with me and then I will compute the AI model, because that's the only reason they're coming to the blockchain, is because it preserves the confidentiality. The interesting part is technology is starting to get developed that lets you do AI in a privacy-preserving, confidentiality-preserving way. For example, you can do something like what is shown in this picture. Imagine that in a trade network, you have shippers, service providers, and of course the network itself. What I want to do is I want to compute statistics at a network level. The statistics could be, like I said, around breakage. It could be around theft. It could be around how often does in this network, I have moisture issues if I'm shipping sensitive material. And you could have many other use cases. Now, what we can do using technology now is to do the 6 steps that is shown below on the bottom. So carriers can confidentiality commit information around how often, what quality of service they have provided. In other words, the quality of service is around breakage, theft, etc. They can commit this information confidentially. What does it mean? They share this information to the blockchain. Only people who are supposed to see the data. And yet it is made available to the network in such a way that the network is able to compute on it. More importantly, shippers are able to verify that the information provided is consistent. So when a carrier says, I shipped this and here is an invoice, the shipper is able to verify that the carrier is not lying. So the carrier is not lying around his or her timely delivery. And the network is able to take the information in step 1 and information in step 2 and verify that these informations are consistent with each other. In other words, the carrier is not lying about it and the service provider confirms that this is the quality of service he or she experienced. Now, what the network can do is able to compute aggregate KPIs. It is able to say, on average, in this month, for these type of goods, here are the breakage information on different trade lanes. And now people are able to use that information to do better insurance modeling, take the right type of insurance, build their risk models, decide how to plan their logistics. And the interesting thing is that this is some information that no one person can compute. It has to be computed collaboratively. And the technologies that let you do these computations are now starting to appear on top of blockchain. So, for example, and this technology stack you see on the right is starting to get built on top of blockchain, where when you want to do AI on blockchain, you have to do AI using sort of these technologies called multi-party computation or zero-knowledge protocols. It's not important what they are, but they are cryptography technologies allow you to do computation while providing guarantees on privacy and confidentiality. So what is beginning to happen in some of these networks is AI is being layered on top of blockchain by leveraging the fact that we have these new crypto primitives starting to appear. This is very early, but as these networks begin to form, this is a pattern that we start to see emerge. And the reason this is powerful is the type of insights you can get out of network AI using this technology, you cannot get on your own. On your own, you can only do analytics on the data that you have, or you can purchase third-party data. But being able to get insights around KPIs or metrics across your supply chain network, using the data that actually flows through that network is very, very, very powerful. And we think that this can be a potentially revolutionary way in which value-added services will start to appear on blockchain networks. And there are many examples. You could do the same thing, for example, on a food network, where you can look to build predictive models for food spoilage. And remember that the chances of when and how food spoils between the grower and the end consumer depends on many, many people. So you can't build an effective food spoilage model without the CPG companies, the food processors, the food vendors, the farmers, or if not the farmers, the contract farming company, everybody coming together and sharing data. But they're all sharing sensitive data. And of course, combining with data like weather. And the point is that network AI allows you to build such network level AI models that no one person can build on their own. So that's the first pattern. The second pattern that I want to go into is this pattern around automation. Okay, and I'm just going to use this just one example to illustrate the pattern because I really want to open it up for questions. But the pattern for automation is the following. And let me give you this example. A lot of what happens on a blockchain network is driven by the ability to create smart contracts, right? Business process logic. Now, often the business process logic or the business rules that you want to create are driven by what is mentioned in the contracts that have been negotiated across these entities. And these contracts are often, or these could be present in regulations and rules. So the checking of, for example, controlled goods in a trading network, or verification of the fact that you are not shipping hazardous goods without a logistics provider who is not certified to handle hazardous goods, or making sure that when you ship something, you're using the right tax rate, the right penalties, etc., based on when the goods were delivered. All of these is driven by what has been contracted or agreed upon or is mentioned in regulations. So one way in which AI and blockchain are coming together is AI, in particular, the field of natural language processing in AI, is being used to process documents like export compliance documents, trade promotion documents, shipping contracts, or purchase orders, invoices, whatever they are. And the information from these documents can be used to extract the business rules that drive what goes onto the blockchain network. So if the business rule between a supplier and a buyer mentions a particular set of terms and conditions for either payment or delivery of goods or acceptance of goods, then the blockchain smart contract can automatically can create the rules based on what has been discovered by AI by analyzing these documents. And it now provides an additional level of automation. What it means is, as blockchain networks, as business gets negotiated, contracts get renegotiated, and we are never going to go away from these documents, right? That's today is how business still runs. You have the ability to semi-automate how that gets enforced on the blockchain network by automatically processing rules. I would encourage some of you to go check out a demo that we had shown earlier in 2018, where we showed how rules controlling transfer of diamonds across the globe, which are, there is a set of rules called Kimberley regulations that are used to control how you move diamonds. And we showed how the Kimberley regulations can be automatically processed by AI, and the smart contract in a diamond supply chain network will automatically enforce Kimberley regulations because it knows what rules to apply when diamond goes through different countries and what checks need to make happen. So that's an example, and there are many such examples as you see in this of AI and blockchain coming together. So these are two patterns. I'm going to spend 5 minutes then on the third pattern, which is the one here, the one here on the bottom, which is blockchain for trusted AI. So the top part is about making AI happen on blockchain. The middle part is AI and blockchain coming together. The bottom part is how can blockchain be of help to AI, right? The former was AI of help to blockchain, and for that we needed to change AI to be able to run in a privacy-preserving, secure way. The bottom is how can blockchain be of help to AI? Now the question is, what is the problem that you're going to solve? The problem is that, as you said before, for broad AI to succeed, there is a need for trust in AI. And why is there a need for trusted AI? Many of you might have seen that one of the concerns around deployment of AI models is we do not have robust systems in place yet to understand whether, for example, AI systems are prone to could be hijacked. We also know that AI systems exhibit bias, and while some of the examples of bias are around only image recognition, we have done a lot of work to show that bias exists in AI models or operate on text. Bias exists in AI models or operate on structured data. So, and there are many regulations across geographies and industries that prohibit you from deploying biased AI models. So, building an infrastructure that allows you to trust, allows you to know that you can safely deploy, monitor, and operationalize an AI model is very, very critical for AI to succeed in the enterprise. And we think of trusted AI as having 4 elements to it. Fairness, which is how do I ensure that my AI models are not untowardly biased on attributes that I am not supposed to be biased on? For example, how do I make sure that my AI models do not bias themselves against gender or age or language or location? Whatever may be that you are not supposed to do either because of the laws of the land or the rules of your company. It's very, very hard when you are building complex AI models over vast volumes of data to actually know that your AI model is biased or whether it is or is not biased. So there's an entire field of work around doing bias checking and creating fair AI models. Then the second part of that is, of course, robustness. People have shown that AI models can be easily hijacked. So how do you make sure that you protect against a new class of attacks against AI models and both check for those attacks and prevent attacks is robustness. The third piece is how do I make sure that AI is not a black box, that you just don't believe whatever AI tells you, you are able to teach AI to explain its decision. So those are all things that are going on in the field of AI. But there is another important piece to trusting AI, which we call provenance. And provenance here is driven by the fact that there is a supply chain in AI also. So what is a supply chain in AI? The end artifact in AI is typically a model. It's a predictive model, it's a decision support model, whatever the nature of the model is. Eventually, the artifact you're deploying is this model on the right-hand side, right? That's what you're deploying. How is the model created? The model is created by taking many, many sources of raw data and going through a sequence of processing steps. You will process them, integrate them, clean them, update them, turn them into stuff that you can actually do AI on. You apply many, many learning algorithms, train the data, actually build an AI model, test it, validate it, and deploy it. And what is happening is in the supply chain where raw data gets turned into an AI model, this supply chain, you can conceptually think of as any other physical supply chain, right? I take steel, iron, wood, or whatever and turn it into furniture or machinery or automobiles or motorcycles. We understand that physical supply chain. Well, here is the same kind of supply chain going across in AI, but we have to do the same kind of tracking because this supply chain is also getting very fragmented. People are outsourcing data, you're procuring data. You might even use external services to label at your data. You might contract out to somebody else to build your AI models for you. But all said and done, you as an organization are responsible for deploying the AI model and for whatever decisions you make. So how do you build infrastructure where this supply chain, not the physical supply chain we have been talking about, but the digital supply chain of AI can be trusted? How can I ensure that an AI model is deployed only after it has gone through robustness checking? How do I ensure that an AI model is deployed only when I can confirm that it has been trained on data from which bias has been removed? All of this requires you to essentially look for auditing, compliance, and quality control of the AI supply chain. This is where we see, this is not happening yet, but we see that eventually that whole supply chain could also start to run on blockchain. Because blockchain, by its very nature, provides that trusted provenance, immutable tamper-proof provenance, which can track that AI supply chain. So as we get into a world where there are data owners, data processors, data auditors, there are model builders, there are people who deploy models, and there are regulators, a blockchain network provides an effective way for that AI supply chain to run in such a way that you can track the provenance of data, you can track the provenance of AI models, you can verify what checks have been conducted on both the data and the model before you actually deploy models in production. And that we see as really blockchain being an enabler of trusted AI. So I really want to end by sort of flashing again, this chart that we have been using, right? The three patterns that I see emerging are what you see on this chart. The middle one is around automation. The top one is around AI allowing you to do more with blockchain than what you do today. And the bottom is blockchain letting you build trusted and safe AI systems. And as I said, both these technologies are evolving. Both have a lot of role to play. AI is about data-driven decision making. Blockchain is about trusted data sharing. So it's not very surprising that you're starting to see intersections. And I think that a lot of interesting innovation, evolution, research will happen as we try to bring these two technologies together more and more. All right, I want to stop my spiel and open it up for questions. I'm happy to, again, I'll keep the charts open in case people want specific questions on charts, but I do want to make sure that I open it up. The questions can be on this topic, can be on any other topic, can be on blockchain in general, on AI in general. All right, I already see a bunch of questions, so I'm going to start responding to them. I will let Lata respond to the logistics around where the recording, where it will be available, etc., etc. Okay, let me start with a few examples. Okay, here is one which says any example in healthcare. I don't know whether the question refers to AI or blockchain, but there are obviously examples of use of both technologies in healthcare. In healthcare, AI is being used obviously around supporting decision support systems for doctors. People are building systems to understand radiological data, to deal with electronic medical records, and really provide. Out of IBM, we ourselves have healthcare products that are trying to provide decision support systems for cancer and for elder care and for many other use cases. The use of blockchain in healthcare is focused around secure sharing of healthcare data. As one example, we've been working with the FDA in the US to set up blockchain systems that allow you to securely share clinical data, clinical trial data. Clinical trial data moves between the places where trials are conducted, the people who work at the drug companies who conduct trials, and the regulator. And so that type of data sharing network is one example of the use of blockchain in healthcare. So that's my response to the question on any example in healthcare. There's a second question on what does hijacking AI mean? Yes, so let me talk a little bit about what has been shown. So few people have shown that the three kinds of attacks can show up on AI systems. The one is you are able to, since AI systems really are built on top of data, one class of attacks on AI systems is, can I do a lot when AI systems are hosted as a service on an API? For example, I build an AI model and host it somewhere for you to use, on the cloud. If you make a lot of requests to the AI in a smart way, you may be able to steal properties of the underlying confidential data on which I train the AI model. So one element of this is attacking AI to get underlying data, which may be confidential. The second way in which AI can be hijacked is people have shown that for certain classes of AI models, particularly certain classes of deep learning visual models, if you are able to you're able to do a man in the middle where you're able to perturb the incoming data slightly. If you do that perturbation smartly, for something that you can't even see from the naked eye, the AI will give completely garbage results. So I will show you two images that both look like a lion, for example. But slight change, there is actually a slight change in the underlying pixels that you can't spot, but the underlying model will give good answers for one, complete garbage answers for the other. Clearly, this is a problem because if I'm going to deploy AI in the wild, the other famous example here is people have shown that A little post-it on a stop sign can cause certain AI models to, not recognize the stop sign. So if you're going to build autonomous vehicles, clearly we want them to be robust and not get distracted just because there was a little sticky on a stop sign. So that's a second class of hijacking. The third class of attacks on AI models is the example is what happened to the Tay bot that Microsoft put out on Twitter, where because the bot was put out live and learns from interactions, people were able to teach the bot to become anti-Semitic, racist, spoof bad language. And in general, when you deploy AI systems where AI systems are going to learn on the fly, which means every request to the AI system is not just a request it responds to, it uses as additional data that it's going to train itself on. Then again, if you are able to bombard the AI systems with different types of inputs, you may be able to take the AI system into areas where it is not supposed to go. So 3 classes of attacks on AI: perturbing the input so the AI gives bad results, using many queries against the AI system to hijack and get data that the AI has been trained on, or properties of the data that AI has been trained on. Or the last one is for AI systems that learn on the job, providing input that causes the AI systems to go off into tangential areas which it was not trained or supposed to go to. So these are all examples of how AI can be hijacked. All right, next question is from S. Vishwanathan. Hang on for a second. Sorry, my questions went away. So the question is around the blockchains that you were talking about, especially for shipping and supply chains. Are these private blockchains or public? So good question. The blockchains that we are working with extensively is less about whether they're private or public. Maybe you mean private, but let me define them to be permissioned blockchains. What that means is, unlike a Bitcoin network or an Ethereum network that is out in the public domain, where anybody can join by just downloading some code, enterprise networks are permission networks, which means that a consortium of entities or some entity decides to come together to run the network, and you must have permission to join the network. So you, just like any other business agreement or arrangement, you join the consortium or you sign up to be part of the network. And then as part of that, you get an identity on the network, you connect your IT system into the network, and then you're able to transact. So for example, today, IBM runs 2 or 3 networks. One network we run is called the Trade Lens network. And today, if you are a shipper, a customs agency, you are a logistics provider, you are a port terminal operator, you can come and talk to us about how to sign up to join the Trade Lens network. So it's public in the sense that you are welcome to join. It runs in common. It is not unique to a control set, but it is permissioned in the sense that you have to ask permission, be permitted to join the network. There are many other, there are also versions which are unique to small organizations. For example, there are many organizations that have set up a network for just their own supply chain. So a big buyer and my 1,000 suppliers, I might create a private blockchain. That blockchain is also permission, which means that you have to get permission to join the network. But it is also private in the sense that that one person, the founder of the network, the big auto company which decides to establish it, or a big financial services company, they decide who gets to join in. So it's not just permission, but they sort of become the controlling authority. So those kinds of private blockchain networks also exist. And again, I want to mention that, look, there's a lot of confusion around private public permission. So I would encourage you to, and we have a lot of videos, YouTube videos that we have talked about on this topic. So I would encourage you to look for them. But the most important thing to take away is most enterprise use cases are permission blockchain networks. Enterprises do not conduct businesses with unknown entities. So, so this world of where you join an anonymous network doesn't work for real business. So there's a question on any comments on blockchain winter, end of blockchain article by Forbes. Look, there are lots of articles that will do both. There are lots of articles that will tell you that blockchain is the best thing since sliced bread. There are lots of articles that will also tell you that blockchains are useless. The answer, as always, is somewhere in the middle. From our own experience, speaking as IBM, where we have been done work globally across hundreds and hundreds of clients, we continue to see an evolution of blockchain from POCs and experiments into pilots, into production networks. We have double-digit number of networks across the globe running in production. In production, meaning that people are transacting and doing their daily businesses. Right here in India, South Asia, we have 3 networks already running in production in various enterprises and for various use cases. And we continue to see more. And we are globally operating 2 industry networks for food safety called IBM Food Trust, and for shipping called Trade Ones, that are actively running and are transacting, right? The food network has hundreds of millions of events tracked. Our Trade Lens networks has over 250 million shipping events already recorded. So these are all networks that are running. So I believe that if we pick the right use case, do not try and use blockchain to solve every problem on the planet, but understand what its value is. There is definitely value. There is no question for me. I don't necessarily see a winter. I just think the winter is called out by people who assumed that this was going to change the world. And I think, relative to that expectation, I don't think any technology can meet that expectation. But the short answer is, it is happening, it is working. We do see increased adoption, particularly in supply chain and in financial services and in manufacturing. We see tremendous increase in interest and appetite for taking blockchain into production. There's a question on blockchain on governance, any use. I don't quite know what governance means here. I believe they mean public sector or government. Yes, there have been lots of discussions on blockchain in public sector. I do see there is a lot of potential, but it hasn't moved as fast as I would say relative to some of the other industries that I just now mentioned. There is an opportunity to use blockchain, for examples, in transforming, the benefit transfer system, in digitizing land record systems, in many processes. Look, a government is a big enterprise. They have complex systems that cut across many arms of the government, that cut across, federal and, central and state systems. So there is clearly an opportunity. It is just that it has not yet become as much mainstream as one would like, as we have seen in the commercial sector. Okay, there is another question on, which is a good one. I do want to make sure. How does a private blockchain help over an EDI-based process for shipping? So good question. The key decision here is, look, an EDI network is still a message passing network. So whether it is EDI or SWIFT, we have had situations where, look, there are standard ways in which organizations communicate to each other. So the picture that I showed here, let me go back to that picture for those who are still following. The picture on the left, you can definitely have a better version of this picture where there is an EDI network here or a SWIFT network, but it is still a message passing network. What does it mean? It means that you run business processes in each organization individually, and then you send messages along the wire. You could send an EDI message, you're still sending a message. What still happens is, that means that the same transaction, the same information is duplicated amongst multiple entities. What blockchain promises is not just sharing messages, but storing data and conducting transactions in one place, so that you don't have duplicate records, you don't have issues of this is what I did, this is what you did, you don't have issues of fraud. So the movement from EDI to blockchain is like the movement from message passing to shared ledger. So shared trusted states that you can transact on is a level of functionality significantly more than simply exchanging messages. That's by the way, the fundamental piece. This is not just true for EDI on blockchain. Trade finance, people have, there is a network in Europe on blockchain called VTrade that uses blockchain to do trade finance. People do trade finance today. People actually use network like SWIFT to exchange trade finance messages between banks. The problem is, all you can do is exchange messages. The rest of the process happens offline. It's not one common scenario. What we are saying with the trade finance network on blockchain, not only do you exchange messages, you can transact, record, update, and everybody sees the same thing in one place instantaneously. And that removes a lot of issues with risk, latency, and many other problems. Okay, there's another question on how can we use AI on blockchain? Please explain in detail. I think I think that is what I was trying to do, and probably I didn't get my message across. When I say AI on blockchain, what I mean is the following. Today, there is ways, technology is starting to evolve where you can build AI models or you can do analytics while preserving the confidentiality and privacy of data. There are many technologies that let you do that. Technologies like homomorphic encryption and pseudo-homomorphic encryption can do that. Technologies like zero-knowledge proofs are starting to mature where you can. So if you do not have a background, it may be a little bit hard to understand. What I was trying to articulate was why that is powerful. Why that is powerful is what sits on blockchain is no one person's data. What sits on the blockchain network is actually data that is multiple people's data. So the AI on that blockchain is really going to give you insights that today you cannot get as in every individual organization. How you make it happen is a little bit different. Today, I do not have the bandwidth or the time to go into the details. I'm happy to, chat with you offline if you want to reach out to me on how these technologies allow you to do computation securely. How can I compute average delay over a shipping network when I can't see any one of the individual invoices? Can I still compute it? Yes, there is a way to compute it under certain situations. That's what technologies like zero knowledge proof allow you to do. I do want to give a plug. Some of my colleagues have recently written an article around this, a blog around this. Maybe I will separately share with Lata a link to that blog. It provides several examples, sort of goes deeper into some of what I talked about today, and maybe that blog will be of value to you. I'm happy to share that blog with Lata, and maybe she can share that along with the recordings of this session. And that'll explain to you how that AI actually works on blockchain. There's another question on AI plus blockchain for process automation. And the question is, can I say that instead of having programmers convey the regulatory documents to smart contracts, AI will automatically create the smart contract for process automation? Yes, I think that's exactly it. The idea is today, you do some automation using AI, you do some automation using blockchain, and in certain situations, you bring them together. You have the opportunity for the automation on blockchain to automatically get created, the smart contracts to get created by AI processing the underlying document. That's exactly the scenario, and that further essentially drives further automation. It's more important because you get into situations where if you have to keep authoring smart contracts every time business engagements change, business rules change, contracts change, then you have a big maintenance issue. So to the extent that you can set up an infrastructure where seamlessly you can create contracts automatically from the underlying business rules using AI, you make the overall system more and more maintainable. But I think you got it right. That's exactly the point. Anshu Sharma wants to know AI plus blockchain, can it be implemented on edge? I'm not sure I understand the question. So sorry, unless you're able to articulate. I don't know what you mean by implemented on edge. A lot of people are doing AI on the edge, which is doing AI on edge devices. There is a piece of work. I don't quite know what you mean by AI plus blockchain on the edge. Sorry about that. There is a question on, do you see a need for use of formal methods, formal verification for any application? That's actually an excellent question, especially if you are a researcher or a scientist. That's a fantastic area because remember, we are trying to infuse trust into the system. So, and today what is happening is, you are right, we are depending on cryptography and the underlying security protocols for a lot of the trust, but still programmers are the ones who are authoring the smart contract. So I think, and there has been some initial work, there's a lot of few prototypes, there's lots of some scientific papers, but definitely there is a lot of room for use of formal methods from software engineering to verify that the smart contracts really do what they are. And would be an interesting place, especially for researchers in the software engineering, programming languages, software verification community, to come and look at smart contract languages. Many of these smart contract languages, by the way, are also not general purpose languages. They are actually simple languages. So these verification methods might actually be able to work well in them. And so that would be a very interesting area for research and innovation. Then there is a question around, is there a success story in the delivery of governmental services, for example, the property development, registration, and recording? As I said, discussion. I do not know of a success story. There have been pilots and POCs, but I think it is less about the technology. It is really about bringing the ecosystem together. Remember that for successful blockchain, right, there are a few things. One is the picking the right use case. Second is the technology. I think the technology is evolving. The third thing is really forming that ecosystem and the network, which is where private enterprise is able to move much, much faster than we have seen examples of government. I do see a lot of potential and far-reaching possibility, but I do not yet have a touchstone that I can come back and tell you this is an example of how this has been very effectively used. There are small countries that have done a lot of work in this space, but I think at scale we are yet to see significant adoption of public sector. All the use cases though have been discussed. Land records, registrations, benefits, benefit system, direct benefit transfer systems. These have all been discussed as possible use cases. Subsidy systems that deal with subsidies. These have all been discussed. Then there is a question, doesn't BC plus AI have a very large gestation period? Blockchain has a network effect issue and AI needs a good enough threshold of data to provide results. It's a fair point, but I think, as I said, and maybe, this is my bias speaking, we already have blockchain networks that have mass volumes of data, right? I gave you examples where hundreds of millions of, food and shipping events have been recorded on some of the networks that we are running. We have networks going into production for example, things like supply chain finance and trade finance, which are dealing with thousands of records a month, thousands of records a week. So I think we are starting to see enough volumes of data for us to begin exploring the uses of AI. Is it true in every network? Not really. But I think at this stage, what I would say is we are at a point where we are trying to build a technology infrastructure. I think I showed this chart of sort of what is a technical stack, right? We are, I think, right now in the business of building these things. But as we build these things, I think we are already starting to see examples of how these can be used. So yes, I agree it is early, but these networks grow very, very quickly. So it's never too early to start thinking about how you might want to apply AI here. All right, the last question, but any smart contracts referred to previous question on process automation created by AI needs to be vetted by all the participants in the consortium for the business process, right? So can this really be automated? Yes and no, it's a fair point. Again, it depends on what is the trust model that you have set up. So remember that it is often easy to verify and confirm than have to update. So yes, you can set up systems where you can automatically do a smart contract update, and then it will not actually get deployed until a few checks are approved and passed by the relevant entities in the smart contract, and you will still do that. But there is still efficiency to be gained by not having to do that manually, but having to automatically process. The other important piece here is, even if AI is used by a developer to create the smart contracts, it still drives some amount of developer efficiency. It is not full automation, but at least now the developer doesn't have to pour through vast volumes of business documents. The AI is able to extract the key business rules for you quickly and capture it, and then you're able to encode it in smart contracts. So again, you are right, that is a fair point, but we have seen examples, especially in supply chain networks, where a lot of the basic matching, for example, matching of invoice to purchase orders, linking line items, linking invoices, many of these today can be done well enough by AI for it. And the AI can also choose to do this by saying, look, whenever my confidence is very, very high, we will move forward and record it on the blockchain. But if the confidence is low, then I will not automatically do it. I will pop up to the human being who has to look at it and authorize. So you can use confidence levels from the AI to figure out how much to automate versus how much to still pop up to a human being to validate. So I think there are different levels of automation here. I'm going to keep moving along. There's a question says, is there a possibility that large companies come together into private blockchain networks and a possibility of smaller firms losing out on poor bargaining power? There is a good question. I think there is a lot of interesting sort of, game economics to be still done around how these networks form. Today, we see sort of, three models for blockchain network formation. One model is founder-driven networks, where one entity decides that it's going to establish a blockchain network and uses their market power to bring people on board. And in those examples, you are right. It's really that entity that's going to get enormous advantage. But today, those entities already have an advantage because they may, for example, be the big buyer. I am a big buyer who deals with thousands of suppliers. I have the market power to force them to adopt technology. I am a big financial institution that does financing. Between myself, a big buyer, I'm a big auto manufacturer, and I am the big banks that I do financing for the suppliers of the auto manufacturer. I do have a lot of market power, so I will be able to get people onto the blockchain network. Do they get more benefits than the suppliers? Yes, but at least those benefits go back to being better financing for the suppliers, so there is indirect benefit. But in founder-led models, you are right, there may be asymmetry in how much benefits everybody gets. The second model are the consortium models, where a collection of entities come together to form a network. This is the example here I would give is our trade finance network in Europe, where 7 European banks got together to create a trade finance network. There, things are a little bit more equitable because no one of those banks has additional market power. They are all peers in that setting. And the other people who come onto the network are the people who are interested in getting trade finance, which are the importers and the exporters. So I think there is less of a asymmetry in who benefits. So founder-led networks do create some asymmetry, consortium networks, less asymmetry. There are the true community-based networks where I think we're still very early in seeing these kinds of systems evolve. So answer is, we don't know. Your question was, is there a possibility? Absolutely, there is a possibility. In fact, there is definitely a business advantage being one of the folks who are early on in creating a blockchain network, because as the network evolves, you probably have a bigger say in controlling how the network evolves, in charging for services, in controlling membership. So, this is something for many organizations to think about. You could always step back and say, I will wait for blockchain to be very, very mature and then join. But then you may lose out on the ability to dictate how that network evolves, right? So that's like anything else, that's a business decision for you to think about. There was a question around, my question was, can we implement AI plus blockchain on edge devices in terms of hardware required? Okay. No, I haven't seen use cases yet of AI being done on edge devices yet, right? So we are still fairly early on just AI on edge devices, let alone blockchain. So yes, there are lots of people working on techniques for compressing AI models, making them work on small memory footprints to run AI on edge devices. So that's definitely happening. And in fact, there is a lot of AI running on all of our smartphones and on small sensor devices. So that's a rich area of work. Are there examples yet of blockchain running across small devices? No, there are lots of experiments, projects, but I don't know of any commercial examples where the blockchain network actually runs all the way to edge devices. We have lots of examples where IoT data lands on blockchain, but that doesn't mean the blockchain actually extends to the edge devices. For example, we have blockchain networks where edge devices, pressure readings, temperature readings, humidity readings, those things get recorded on blockchain. But that's just one-way traffic. Data from the edge devices goes through a blockchain smart contract and lands onto the blockchain system, but the device itself does not participate in the blockchain network. So no, that has not yet happened, except maybe in some interesting research projects. So the answer is, have there examples of AI plus blockchain on edge? Thus far, no. Okay, we have talked about a lot of examples around formal methods. I just want to make sure I'm not missing other questions. So let me go there, and then if there aren't any, I will come back to that question. Okay, there is somebody who has said, I'm in a rapidly growing automated construction startup, and a couple of years have passed by without a proper ERP system. Now, a serious attempt has been taken to business process mapping. How should I take this initiative into an AI/blockchain discussion? So my response here is, what I would do is, look, blockchains are not replacements for ERP systems. ERP systems lets you manage your business processes well. They do establish connectivity into other systems and let you do that. So blockchains will connect into many of the implementations we have done. Blockchain systems connect to ERP systems. They may get data or put data back into the systems. Blockchains connect into core banking systems. Blockchains connect into loan management systems. Remember, blockchain lives between organizations. Systems like core banking, ERP live within organizations. So it's not an either-or question. It is a how do I integrate question. For example, even to be even more concrete, we have run many networks now where we do supply chain financing. The blockchain network runs across many entities, but in each entity, the actual interface, the APIs between the blockchain and the application other side is often an ERP. It's either SAP or something else. In another example, we connect between blockchain networks into dealer management systems when we are doing work in the automobile industry in dealers. We do connects between blockchain systems into something like, let's say, JD Edwards, which is another supply chain system. So think about them as complementary, not as either or. There's a question on what are some of the most popular implementations of blockchain in banking. Yeah, so I think I flashed this chart, so maybe I will sort of quickly go back to that. So one area we have done work around, obviously, trade finance. So that's definitely one example. Supply chain finance is another big use case. We have done work out of our, out of our customers in Australia around this notion of bank guarantees, building a blockchain network to enable trusted bank guarantees. And then there's a lot of work, obviously, around payments and clearing and settlement systems. So those, I would say, are the big ticket ones where we have had a chance to work on use of blockchain in banking. There's a question. AI compute does require a high bandwidth connectivity for real-time learning or training. So is the assumption that there is an inference model in each subset of the network? Okay. So you have to be careful as to what we are saying here. The AI model doesn't have to necessarily be built in a distributed fashion. It only is so the example that I said, the network itself is going to host an AI model that is going to, let's say, predict the chance of breakage, right? Shipping breakage probability. Now that model is going to get trained in one place using a set of raw data, but that raw data is going to be gathered in a privacy preserving manner. So AI on blockchain doesn't mean AI itself has to run in a distributed manner. It only means that the gathering of training data and the basic features and the input data, that happens in a privacy preserving way by everybody contributing zero knowledge proofs and so on. But once that is available, then the actual computation can even be done in a central manner, and that's okay. The key here is the sharing of data happens in a distributed manner by preserving privacy. The AI model could still be built in a centralized way. Now, yes, there is an approach to look at building AI models through secure multi-party computation, but that's very, very, very early. And in those scenarios, you are right. There is quite a bit of work to be done to make multi-party computations really, really scale. So I would say that's very, very early in technology. And people are looking at how to scale them, make them effective. At this point, I wouldn't say that any of this is ready to operate on massive scale networks or edge devices. It will still require high bandwidth connectivity to work in the case of secure multi-party computation. Okay, I think we have run out of time. I'm just going to end with one last question. Have you, IBM, implemented blockchain or AI on any countrywide goods and service tax system? So I'm just going to respond and say we have done GST implementations, not at a national level, but I've done DST related blockchain implementations with multiple organizations within the country. What that means is we have allowed organizations and their ecosystem to ensure that their GST filings are accurate and do not have mistakes. But they do, of course, directly file against the GST systems, but we provide better supply chain coordination that makes their filings accurate and correct. So the short answer to the question is we have built systems, blockchain-based systems that are in support of GST as opposed to do GST themselves. Let me put it that way. That's the easiest way I can think of answering your question. All right, folks, thanks for exciting participation. I know I couldn't answer every question. There were far too many, but I hope I touched upon some of the most important ones. Thank you again for joining me. Good luck. Have a good evening, good morning, wherever you are in the world. Thanks. Bye-bye.